Hi everyone. All right, so today we're going to do graphing in vertex form. So we're revisiting the vertex form, revisiting the graphing of quadratics with this new form. Originally, when we had talked about it, we had talked about the transformations that go along with it. But here we can kind of see how that hopefully applies. So the first one I want to do is number 2. I'm going to jump around, try to make this as quick as possible for you. So for number 2, we have y equals 2 times the quantity x minus 2 squared plus 5. So from our vertex form conversations, we can identify our vertex here, which are the h and our k. Okay, h and k here. Remember, it's always the opposite of what h actually is. So this is going to be a 2, positive 5. So then our axis of symmetry, if you remember, actually goes through our vertex. So that's at x equals 2. So I can put on my graph x equals 2. I'm going to put my invisible line. Okay, I'm going to put my invisible line. I know my vertex goes through 2, 5. So 1, 2, 3, 4, 5. And then my question is asking, do I have a max or min? So you would look at your a value here. So if you remember, a is this 2 out front. Okay, it's in that place. So here a equals a positive 2. So that means we would have a minimum because a is a positive number. So it's facing up. Okay, so we're going to make a quick little table so we can plot the rest of our points so we can graph. So if I'm using my axis of symmetry to help me, I'm going to use 0, 1, 2, 3, and 4. I'm using my 5 points. So if I plug in 0 to my vertex form, 2 times 0 minus 2 whole thing squared plus 5. Negative 2 squared is positive 4. So I should get 8 plus 5, which is 13. And then I'm going to do the same thing for the rest of them. Okay, and it should be symmetrical. So if I plug in 1, 1 minus 2 is negative 1. Whole thing squared is a positive 1. So then I should get 7. So same idea, 3 minus 2 is 1. Whole thing squared is 1. I should get another 7. And then 4 will give me 13. So I can plot a couple of these the best I can. So I can at least plot the 7s. And if you remember, this is my y-intercept. Okay. And then one of my points should include my vertex to make my 5 points a little easier. So in your homework, you're going to see a list just like this. Okay, so I want to make sure we're doing exactly that list. So we did our vertex. We did our axis of symmetry. We said it opens up. It's a minimum. Okay, our value, you can just put the point. Some people are particular about it's got to be x equals, some are y equals. Just put the point. And then we found our y-intercept. It's at y equals 13. Or you can just list the point as well. I think it's easier to list the point because then you're covering all your bases, but that's just me. And so the last thing we're going to do is we're going to find our domain and range. We're going to practice that again because we talked about it and then we stopped and now I'm going to bring it back. So domain and range, if you remember for quadratics, your domain is all real numbers, so negative infinity to positive infinity. And then our range, if you remember, is our down to up. So I'm going to start from the bottom of my graph down here and go all the way up until I have a point. So this is actually my starting point for my range. I'm going to include the value 5. And because it faces up, it's going to positive infinity. So it didn't ask for domain and range. I'm including it because I want to practice that again with you guys. I think that's important that we continue practicing with domain and range. It's not going anywhere. So we answered all of our questions for this one. We're going to move to example 4. So we're moving down to example 4. I wanted to do an example where we did not have it in vertex form already. So we are given y equals x squared minus 2x minus 5. So in order to graph this, you can do it the way it is. I want to put it in vertex form first. So I'm going to go ahead and go through that process again. Okay, we did learn how to do it without vertex form, but since we know how to put it in the graphing form, which is the vertex form, that's how, it's easier for us to graph like that, because we can find our vertex a little easier. I'm going to go ahead and put it in that form. So I'm putting in my boxes. Okay, I'm going to do my b divided by 2, so negative 2 divided by 2, get my negative 1 square. So I should have a 1 going in those boxes. So now I have, because a was 1, I don't have to divide anything out, so I don't have to worry about all of that other brackets or anything. I should have x minus 1 squared. If you remember, this b divided by 2 goes inside. And then we've got our minus 6. So this means, I'm just going to put it over here, my vertex is at negative 1, 6, which means my axis of symmetry is at negative 1. So if you did the opposite b over 2a, if you remember, opposite b would now be a positive 2, 2 times 1. Okay, so quick little fix, positive 1. So our axis of symmetry goes through positive 1. We would have to go through and plug in that 1 and do it algebraically. So if you went ahead and did this, because that is what we learned, that's fine. But now that we have vertex form, we don't need to do that. Okay, so now we should have a minus 6. Okay, so the next thing we need to take a look at is we need to take a look at whether it opens up or down, if our parabola opens up or down. So our a value, which should match our original trinomial in our vertex form, is positive, so it's going to open up and it's going to be a minimum. Okay, and again, just put the coordinate, because then you're covering all your bases. Every teacher is different, so if they say, well, you need to put the y value or the x value, I'm just going to have you put the coordinate. You already have it, you already know it. Not trying to make it more complicated. So go ahead, I'm going to put in my 1, 2, 3, 4, 5, 6, my vertex, and then I'm going to find my table of values using my axis of symmetry. So again, I'm going to do my 5 points. I know one of my 5 points because that's my vertex. And because we have our standard form here, our expanded form, this is our expanded form up here, the x squared minus 2x minus 5. I know my y-intercept because that's my c value. Okay, so c, which is also my y-intercept. Okay, which I can actually, oops, that's not in the right place. Good one, Mrs. Conine. Negative 5, which is C, which is your y-intercept. See, it just proves we all make mistakes. And we can just fix them real quick. So I'm going to put 0, negative 5 as my y-intercept, and I'm just going to find my other values. Okay, so if I plug in negative 1, so negative 1 minus 1 squared equals negative 6. This is negative 2 squared. Positive 4 minus 6, I should just get a negative 2. And that's exactly what you can do to find your values. You can also check your work. Check work using your calculator. Okay, so make sure you're practicing and checking your work using your calculator, because you will have it. If we have a Regents, you will be able to use it. Regardless, whatever final we have, you will be able to use your calculator. So if you remember, this is all symmetrical, so if I plug in 2, I should get negative 5. If I plug in 3, I should get negative 2, so we're just going to check that real quick. This does give me -5 because 2 minus 1 is 1, squared is 1, minus 6 is -5. So 3 minus 1 is 2, 2 squared is 4, and then 4 minus 6 gives me a -2. So it does match up. I did my algebra right. And then I can just graph those coordinates. Okay, so again, the last thing I'm going to have you do is I want to do domain and range just to review that real quick because it's something we definitely need to keep talking about. So domain and range somewhere on your paper. Domain is always all real numbers for quadratics. Okay, for quadratics it is always all real numbers. So now your range is going to be where either you're starting from negative and ending at a point, or you're starting at a point and going positive. Because it's a minimum, we are starting at the minimum and then going up from there. So we have a -6 going all the way to positive infinity. And that's it. So your homework is attached. Just make sure you follow directions. So for 1, 2, and 3, identify the vertex using your standard form. So if it's not in standard form, you need to get it in standard form. And we talked about how to do that again in example 4. So we would find our vertex using the old school algebra way that we talked about. And then you're going to have some graphing that you need to do. So make sure that you go through and you answer those questions and graph them. All right, if you have any questions, come and see me during our office hours. And other than that, have a great day.